Last week, we successfully implemented the basic control functionalities for our Fox character. The Fox is now capable of freely moving left and right within the 2D game scene and has a fully functional jumping feature. Now, let's delve into the accomplishments of this week. If the Fox happens to fall below the ground, the game will restart. The cherry count is displayed in the top left corner, starting at 0. For each cherry the Fox consumes, the count increments automatically by 1. The frog enemy moves left and right by default. When the Fox collides with the frog, it is pushed back a certain distance. If the Fox jumps and collides with the frog from above, the frog disappears. Next is an overall demonstration of completing the first level. Upon reaching the endpoint, pressing the E key will allow you to advance to the next level. This feature will be implemented next week. Next, let's use code files to explain how to implement these features. By inheriting from the enemy class, we've implemented the frog's left and right movement as well as its jumping behavior. In the start method, we set the movement range and initial position, and in fixSetUpdate, we call the switchEnum method. The movement method handles the frog's movement logic, changing its orientation based on position, and triggering jump animations, and applying velocity upon colliding with the ground. The switchEnum method manages the transition of animation states, including the shift between jumping and falling states. Overall, this code provides the foundational framework for the basic behaviors of the frog enemy. In the Eagle class, we achieve the periodic vertical movement of the enemy eagle by setting the range and speed for its upward and downward motion. In the start method, the initial range for vertical movement is obtained. The update method calls the movement method every frame, which adjusts the orientation based on the current position in relation to the specified range, and sets the vertical velocity using RB velocity, thereby realizing the eagle's cyclical upward and downward motion in the vertical direction. Next, we will explain how collisions are implemented. The onTriggerEnderToD method is utilized for managing collision logic with ToD triggers. When a game object enters an area with a ToD trigger, this method is invoked. Initially, it identifies the type of collision by checking the tag of the collided object. In the case of collecting items like cherries, it performs a series of actions, including playing a collection sound, destroying the object, updating cherry or gen counts, and refreshing the UI display. If the collision involves reaching a death line, it disables the player character's audio component, plays a death sound, and invokes the restart method to restart the game after a 2-second delay. The onCollisionEnderToD method is used to handle collision logic with ToD colliders. When a game object collides with another collider, this method is called. If the collided object is an enemy, the script of the enemy is obtained. Different actions are taken based on the player character's state. 1. If the player is falling, it triggers the enemy's jump-on event, causing the enemy to disappear and the player to jump. 2. If the player is on the left side of the enemy, it pushes the player to the left, plays a hurt sound, and sets the hurt state. 3. If the player is on the right side of the enemy, it pushes the player to the right, plays a hurt sound, and sets the hurt state. Finally, The restart method is responsible for restarting the game. It achieves this by reloading the current scene using Unity's Scene Manager. This ensures that the player is taken back to the beginning of the game, effectively resetting the game's state to its initial configuration.